welcome all. As always, some context here. These are the core dev calls for core contributors to present what's been working on, discuss upcoming features and protocol changes with community members like you. While there is some time for Q&A after each topic, I do encourage you all to continue the conversations in our forum, Discord, and GitHub. Everything is out in the open, and we do want your feedback. I'll also paste a link to the Graphs ecosystem calendar in the chat because I realized some people are not subscribed. And yeah, do subscribe so you can join and participate in all these discussions in the future. Lastly, the core dev teams are posting monthly general updates on the forum, and I highly encourage you to check those out. I'll also share those links here and attach it to the show notes. Now, on to the agenda. What do we have today? So we'll start with Substreams. We have Giuliano from StreamingFast. I think he will walk us through the major developments with Substreams. I know the team has been very busy improving the development experience. We've touched on the SPS CodeGen, based development experience last time, I think 2 months ago, and yeah, and I think this was Alex Bourget. I'll share a link as well in the show in the chat so you can check it out. It's on YouTube as always. Next, we'll have GraphNode and subgraphs. Paka unveiling a little bit of what the team has been researching and experimenting with. These are features that should be available to everyone very soon. Among other things, I believe we'll talk about indexing time composition, which we've also discussed. Okay, Paka is nodding, which we've discussed before. But yeah, it's good to see some major progress there, and finally it will be available to all. Lastly, we have the GIPs, well-advanced GIPs that are on our GitHub repo, also on the forum. The second one is on the forum, not the first one. But yeah, starting with the first, improvements to the existing Epoch block Oracle by the Wonderland team. The team has been working closely with EdgeNode, researching on how we can improve the design of this critical component. They've authored the GIP, which is always nice to see, and are now close to finalizing the entire implementation, while also making it compatible with Horizon. I think that's coming. On indexing fees, this is the new GIP. It's a simplified version of a previous one, GIP 58, on indexing fees. On indexing payments. It's replacing what we called before indexing fees. So we'll discuss the plans for an upcoming semi-trusted MVP that aims to solve the shortcomings of the curation-based system. And we'll also talk about what the long-term plans are for Horizon and Subgraph service. So that's the agenda for today. Again, apologies for my voice. And I'm still getting people in, that's why I'm a little bit distracted, but I think we can get started. So I'm going to stop sharing my screen. And Giuliano, you should be able to share yours and speak whenever.
Hey, hi everyone. So I'll be presenting, I guess, some of the updates on our end. I did not know that I had to share screen, so let me just.
No, you don't have to. It's fine.
Okay.
It's okay.
Yeah. But either way, I mean, I can show off some things, but I guess I'll start off with what are some of the major updates we made, right? So one of the major updates that we did make was, first of all, there's a greater plan here about integrating Substreams better part of the Graph platform, right? Making it a proper data service and doing the proper steps and to make that a good experience for the end user and fits the network requirements. Now, one of the important things to do there was to revamp Substreams.dev. So to have a place where users can come, land, access available packages so that they can reuse other people's work, and additionally access the docs, access the dev container, access grabbing keys faster, and make that really aid the Graph experience. So that was one of the major things that we shipped this quarter, and I can share my screen and show that. So that's kind of this right here, Substreams.dev. And one of the really nice things that we're doing in Substreams.dev is bounties, right? So we're trying to test what value is brought from incentivizing users. And one of the things you'll see here is if you go to the bounties page, and you can see there's going to be weekly rewards to the user who created the most used and popular package, right? So for example, in week 1, so I think 2 weeks ago when we started running this, we had 87 users who reused this specific Substreams package. And this is kind of a way that we're trying to, grow the community and incentivize people to build, right? Another big advancement that we made is our support for Solana, right? So Solana, it's being treated as more of like a high priority, right? There's a lot of users, a lot of dApps are moving into that arena, and we need to be there and be present to properly fill those needs. One of the few of the things that we listen to users are important in the Solana ecosystem was one, performance. So for them, throughput and latency are of most importance. So Substreams has no caps on throughput, and latency officially as of this week is faster than an RPC. So like if you're running an RPC on premises yourself and polling that RPC, you're extracting data directly. We have now, instrumented specific things. I'll leave it like plugins that we've written so that now the latency is quoted about 300 milliseconds faster than an RPC. The other thing, that's very valuable. The other thing that we've done there is we launched account changes. So that's being released out of beta. Account changes is essentially, your deeper data model that you have in EVM, like some traces, like balance changes, for example. And account changes are very important to Solana users. And historically, before us, there was no source of history. So it was Yellowstone. Yellowstone's outputting these things in real time, and they're not saving it. And if there's disconnections, you miss out on the data point, for example. So we've solved those friction points, and now we started aggregating data as of October for accounts, and we're serving this to end users. And the final feature we launched was native IDL decodings. So people are coming from EVM who are transferring over into Solana, and they're looking for similar experience. They're used to APIs. They're used to working with human readable data, not byte data, or encoded data in like base 64 or base 58, right? Like, so what this offers really is that native decoding experience. So IDLs is written by this library called Anchor, and essentially this is supposed to be the standard in the ecosystem. So we're trying to back that standard. Those are some of the feature updates with Solana. Of course, there's going to be some integrations of substreams within the graph.com platform. And we're working on that to make that, a unified experience, really helping the end users understand what product best fits their specific need at that moment in time, right? That's the most important thing to us. Regarding the dev container that Pedro mentioned, we haven't made many changes from that point. We've made optimizations and performance improvements, and there will be there will be more, DevX improvements, I would say, in the next quarter in regard to that dev container. Another thing that I can touch on here is, the users. So obviously we've integrated a few non-EVM chains to the graph recently. That's, Mantra, Injective, Starknet. We also added, for example, Say. So Say wanted a parallelized data service that met their parallelized chains needs. Now, but if I really like double click into the users there, who is really evangelizing DeFi for these platforms, right? And that's propeller heads. So one of the big success stories of this past quarter, amongst many exciting users that have joined onto the product, major organizations, but one who's really aligning with the values of the graph is propeller heads. They've decided to open source their solvers. They've decided to essentially write a client on top of these solvers so that users can easily call Tycho, that users can easily build and integrate these solvers into their platform. But really what this is doing here is that as becoming this open source standard completely built on top of Substreams, Tycho has now, or Propeller Heads, has now made a big impact in the market. They're seeing, for example, on CowSwap that they are covering over 15% of the order flow, right? So this is becoming very, exciting that our data products are being used as kind of the intelligence or the infrastructure layer for these other infrastructure and platforms integrating, right? So exciting news, yeah. I think that covers a lot of like the important points.
So, one thing I should probably mention is we already have a link to substreams.dev within the Explorer, right? So people browsing available subgraphs on the network can also should also check out substreams.dev. Again, a unified proposal is in the works, but it's a good starting point. All right, cool. Paka, do you wanna go next?
Yeah, sure. Cool. So in case y'all don't know me, I'm Paka, PM for GraphNode, data services at EdgeNode. This broader update, it's titled GraphNode Updates, but we're really going to be focusing in on kind of one, I guess, enhancement set or feature set that we're really stoked on for 2025. And so that's composition that we kind of alluded to earlier. Let's just jump into it. So composition at a glance. It's not going to be a super deep dive technical overview of composition in terms of implementation in GraphNode or how to actually program a subgraph using composition. Kind of higher level, trying to help people understand how the system has changed and why we think this is pretty cool. And also some fun AI generated images. And so the composition kind of story is part of our broader narrative of next-gen subgraphs, which is kind of aligning with a change in pricing and kind of a bundling of feature enhancements that we've been working on over the course of 2024. So a few of those are aggregations in subgraphs, declarative ETH calls in subgraphs, and then the kind of trifecta is the composition in subgraphs. And so we're really excited to bring this kind of offering to market in 2025. And so composition is going to be the focus of today, but aggregations and declarative ETH calls are features that very much play into this composition paradigm of developing subgraphs. And so I assume I'll be back once we have more demos and I'll be able to show in more depth. But composition will let users build subgraphs that are modular and reusable, really improving developer efficiency. So instead of duplicating effort on foundational data extraction, users can really just implement new features, which is kind of the end goal, and being able to extend existing artifacts. And composition will really encourage a more interconnected ecosystem of subgraphs where our community can kind of contribute building blocks that others can then extend and reuse. And so distilled to a TLDR, subgraphs are becoming a data source for subgraphs. So I have a few diagrams that I want to use to kind of explain a high-level summarized, maybe simplified version of the current state of the universe for subgraphs and what composition changes about that. And so bear with me on this very gray diagram, but I think it'll be explanatory shortly. So right now, in a pre-composition kind of developer paradigm, subgraph developers are often kind of forced to reinvent the wheel or almost reinvent the wheel. In this case, we have two subgraph developers in kind of their separate developer bubbles. They're both interested in smart contract ABC123 on Ethereum. However, they might have slightly different business needs and so slightly different assembly script mappings as a result. And so this produces two distinct subgraph artifacts, which then a SAD indexer must process, likely in duplicate, many of these events, which is just a bummer for everyone involved. And unfortunately, SAD subgraph dev Karen is forced to kind of contribute to data duplication because at this point, they can't really extend these subgraphs. Conversely, or not conversely, but on the flip side, in the case where there's perhaps different subgraphs that are of interest that are indexing different smart contract addresses, SAD Steve, he can't really reuse these distinct subgraphs. He could send separate queries, but if he just wants to reuse this artifact in the current state of the universe, that's not really possible. And so SAD Steve contributes to yet more data duplication on the network and creating kind of redundant artifacts that people don't necessarily need. So before I kind of pivot to an after composition paradigm, just want to quickly check in if this generally tracks with people, if there's any kind of glaring errors or confusion that you want to point out. This can be kind of interactive chat, but feel free to interject at this point before I transition to what's coming. Not hearing anything, not seeing anything, so I'm gonna keep going. But yeah, I guess the TLDR of this pre-composition state, we have a lot of redundancy. We can't really reuse data artifacts. That's a bummer for end users that are subgraph developers, our indexers. It's just confusing for everyone. It's just more infra to run. It just kind of sucks. Before we jump into a post or an after composition paradigm, just wanted to give a little palette cleanser because that was a lot of gray. And these flamingo goats are pretty cool. With composition, we're entering this new reality where suddenly the interconnectedness of subgraphs becomes very richly complex in a good way. And so I just want to highlight here, suddenly in this with composition world, our data artifacts are becoming much more reusable and interconnected. And so we have multiple subgraph developers creating artifacts. We have a subgraph for different smart contracts, and then indexers are able to reuse saved entity data from subgraphs in other subgraphs. And so in this case, subgraph Mary can extend a pre-existing subgraph using data that an indexer already has and applying custom mappings and entities, which is pretty cool. And so it's kind of slowly contributing to less duplication, more reuse of data, optimizing infra, but then also contributing to network effects whereby there's tons of artifacts that people can kind of extend on the network and build as if they're Legos. Kind of a little bit of foreshadowing here with these blocks. But a lot of us at EdgeNode are really excited about some of the implications for data reuse on the network and also just operations for indexers. I'm not going to necessarily walk through this entire diagram because there's a lot of, I guess, redundant arrows for the sake of explaining if you had 10 minutes to read through it. But I'd encourage you all to pause the recording at this point if you'd like to spend a little more time walking through this. And likewise, the slides will be shared afterwards. But kind of a little more forward-looking, that end state that I just described, we're almost there, but we're not quite there. And so I'm really excited for the next 2 quarters of work because I think this is really when the rubber meets the road and we're going to be shipping some cool stuff for users to try out and offer feedback on. So in Q1, essentially after the holidays, we plan on shipping the kind of single subgraph data source composition feature set, and quickly thereafter, probably late January, releasing support for aggregations within composition, and then more than one subgraph data source from the same network. And then less on the developer side and more on the sharing kind of content. We're working on additional demos to kind of explain this feature set and why we think it's a beneficial new way to develop subgraphs, but also starting discussions across core devs on how we can apply composition in the context of interesting products for chains. I'll leave it at that as a teaser. And then for Q2 and beyond, also kicking off some discussion on how we can really revolutionize the CLI and UX experience for discovery and authoring. Right now, there's some limitations to discovering what data is already available on the network. And so we think pairing this enhanced discovery experience with composition will really transform how builders are interacting with the graph. and then potentially subgraph data sources from different index networks, i.e. like a multi-chain subgraph, which would be pretty cool. But that's more of a, we'll see. But that's all I have for today. Kind of opening it up for Q&A, but happy to discuss async as well. So don't hesitate to reach out.
I have a question.
Yeah, sure.
Go, Matthias. Yeah.
I'm wondering how is this going to look from the indexer side? So if an indexer wants to index a subgraph that's composed of other subgraphs, does it mean that it has to index all the subgraphs that are part of that composition, or can it partially index only the entities that are required for that composition, if that makes sense?
Yeah, it'll sort of similar but different to how indexers need to handle grafting. They'll have to support those other subgraphs. And so we're at the finish line of offering the automated tooling for grafting, and then we're quickly going to pivot to basically automating that for composition. So indexers just wouldn't have to worry about it. So I didn't highlight that, but that is also coming in Q1. Just an automated indexer experience, so it's just smooth. People don't have to worry about it because it is quite annoying if it's not automated.
Very cool. Did you say demos were coming in January as well? Was that?
Yeah, so we already have a demo. It's just you can't really. It's more of like you can see it, but you can't use it on upgraded indexer or in the studio yet. But we have one demo that's available. It's a little more complex, and so we're working on a few that are simplified. And so I can share links to the more complicated demo that you can perhaps share with the recording. And we'll share more basically in Q1. We plan on having a lot more content.
Just checking the chat, and Mark Andre, an indexer, is saying, side indexer here, excited about this.
Heck yeah. No, that's good feedback. Yeah.
Yeah, I guess a lot of people will be happy.
And yeah, just generally, in terms of graph node things or graph CLI things, don't hesitate to spam me on X, open an issue on GitHub, or tag me in Discord. So yeah, just putting that call to action.
So hopefully next month or the next core dev call, we'll have a live demo of sorts.
Yeah, definitely.
Cool.
That's
That'd be nice. That'd be nice. All right, let's move on then. Yes, the Wonderland team. First time here. You're very much welcome.
Yeah, first time.
Hey, Shai.
First, thank you, everyone. Paka, that was a really good idea. I really loved the talk. So yeah, I'm really happy that people are working on that. I'm trying to present my screen in the meantime. There we go. So my name is Shaito. I'm an engineer manager for the Wonderland team. We have been working with Edge and Node. And first, I wanted to personally thank Pedro, Pablo, Tomas, Miguel, and others from Edge and Node. You really helped us, and it was a blast working with you. So yeah, presenting GIP 80, optimistic EVO, synchronizing the multi-chain world for decentralized reward distribution. Just as a background, first, to clarify what is the EVO. The EVO is a system that's already in place for the graph. It's the source of truth for chain synchronization and reward distribution. Why this is helpful is because now it's been a while, but the graph is now paying the rewards for every chain in one chain, which is Arbitrum. We need to synchronize the clock between all of the chains that the graph works on to pay the correct amount for each indexer. It's comprised of three parts: the data edge, the RAS process, and the subgraph. And it works basically by an operator running a RAS process that posts updates into the data edge that are then indexed, so that indexers can then use that data to generate their proof of index, their POIs. The problem with that, we identified three main ones. The first one is that there is a single operator risk. The RAS process is run by a single operator. So this could fail, this could stop running, or this could maybe get updated at some point and have any issues. There is the liveness risk, because we have just one operator. If the operator goes down, then we could have either latency or a down system for a long time. And the last one is fork risks, because there are multiple chains. Then there could be an uncertainty if a fork happens on a chain. So it's difficult for the single operator to decide. The solution that we found is, or that we think is the correct one, is something that we developed in-house as called Prophet. It's an optimistic oracle that is fully adaptable, and it allows developers to have complete control over everything that happens in the system. Basically, any developer can build custom modules to change the functionality of Prophet so that you can get any data as an oracle as you want. Here are the 2 repos for the, I'll show them at the end too, but here are the 2 repos for GitHub if anyone is interested. Why we think Prophet is a good idea? I think there are multiple ones. First, because it's optimistic in nature. The good thing about it is that when good users post good results, the gas, it's really efficient. So gas costs are almost nothing. And then when bad actors try to attack the system, it's really costly because there are a lot of systems in place to stop them. There is high redundancy because anyone can participate in the system to make it more robust. No changes for indexers because it's a completely sidelined system. Although anyone can contribute by running the agent that we are building that does all of the requesting and the proposing and also disputes any incorrect response. It also has its own, that I'll explain later, dispute resolution system, which is something that we came up that makes it really, really expensive for bad actors to attack it. And the last one, because it's fully customizable, it's easy to integrate with Horizon. So basically, for the stake needed to participate in the system, we use Horizon for staking and for slashing any user that tries to act in a bad way. The most important part about Prophet, it's its request life cycle. First, the request is created that has all of the parameters, all of the modules that will be used, and all of the configuration. Then any user can propose. If no one finds that bad, if the answer proposed seems correct, then after some time we can achieve finality, which means that the data is posted into the data edge and it can be indexed to be used by the indexers. If someone finds that maybe they were mistaken or they were trying to attack the system, you could dispute it by posting a bond. It would go into the dispute resolution system first, which is a bond escalation system that I'll explain in the next slide. And if that doesn't solve the problem, we also have a resolution system at the end, which is the ultimate source of truth, which is a council appointed by the graph, which will decide the final answer for that request. So it can finalize and then go directly into the data edge. So, continuing with that, here is the bond escalation mechanism that we came up with. The idea is that when people start, when you post an update, or when someone disputes, the cost is really minimal. And then if we get into a disagreement, we can, in rounds, post more bonds until the system configuration says that it's at the limit, or until someone says, okay, maybe I'm not that sure to continue posting more bond. So basically, it's a loop where the one party decides to increase the bond, and then the other party has some time to increase the bond, or the other one wins. This goes through a couple cycles, depending on the configuration that's easy to configure, and the amounts are also configurable. And then you have 2 options after that. Either this resolves the dispute, so one user decides to back off, or the other solution is we call the resolution module, which is the console that I spoke about before. There we go. So this is for the console, which is the ultimate source of truth. Internally, we discussed a lot of options. We think this one is the best and the safest one. One was using canonical bridges. So it's very safe because you are 100% sure that the answer is correct, but it introduces a lot of delay. For example, if you have all of these optimistic rollups, you would probably go into the 7-day delay, which is quite a bit of time to answer everything, and it's probably pretty costly. The second one is using third-party bridges, which are less secure, but they could be way, way faster. The problem with that is that we are introducing a lot of trust assumptions into the system, trusting these third-party bridges and giving them a lot of power into deciding that. So if they get hacked, then we would have a lot of issues. And lastly is using an arbitrator, which is the one that we decided in the end. The good thing about this one is that it's really efficient. It costs little money, and it's easy to set up. That's the most important part. So let me show you. There we go. It's qualified individuals selected by the Graph's governance that can decide in the last instance only, and only for requests that have reached the end stage. So basically, they got disputed, they got escalated up to the maximum point, and then just after that, it goes through the arbitrator first to decide who was right and to close that request. So continue. There are some resources. We already wrote the GIP. It's still in the process. I think it hasn't been approved or merged yet, but it still has time. If anyone wants to read it, please feel free to add any comments. We also have the repo for Evo Core and Evo Agent. Evo Agent is the process that you can run to participate in the network, to create requests, to create and to dispute false claims. And then we have the Optimistic Oracle Prophet, Prophet Core, and Prophet modules, and some documentation. Yeah, I think that's it. I'm Sirek Shaido in Twitter, sorry. If anyone has any more questions after this call, please feel free to ping me or to ping Wonderland too. But if anyone has any questions right now, feel free to add anything. Yeah. Awesome.
Thanks, Shaito. Looking at the chat.
Thank you, everyone.
Yeah, thank you, Shaito. And just want to make it clear once again that it's always nice to see different authors working on GIPs and doing such core work with other core dev teams. So I appreciate that. That was an awesome job. Again, do review the PR. I'm going to link it here as well because it's getting ready. It's almost ready. All right, let's move on then. I guess the next JP is gonna be either Pablo or Matias, right?
I'll be presenting. Thanks,
Okay.
Pedro. Let me just set this up. Okay, there we go. So I'm going to be presenting indexing payments, formerly known as DIPs or direct indexing payments. There's a GIP. It's 0081. It's currently live on the forum. There's a link here on the presentation. I'll share it in the chat or somewhere else that Pedro gives me access to, so that anyone looking at the recording can chase it up. But yeah, let's just jump straight into it. So what is indexing payment? It's a mechanism by which a gateway can pay an indexer to serve a subgraph. And a lot of you might be wondering, we already have that, and that's with curation plus rewards. So we were looking at creating an alternative to that. And there's some key reasons why we're looking for an alternative. First, we want the alternative or the indexing payments to be an easy way for developers to get subgraphs indexed. And easy in this context is doing a lot of the heavy lifting here. Essentially, we're looking for a way for this to be non-GRT based, So developers can go and pay straight through fiat. We wanted it to be a regular and predictable billing, so that developers know upfront how much they have to pay, and they will pay that regularly, as opposed to having to buy GRT and hold it. And we wanted for there to be a predictable performance as part of this sort of indexing agreement. So what can happen right now is, through curation, you can signal a subgraph. And then, although the network generally does a great job at providing indexers that have great performance, there is no guarantee for that, right? And there is no recourse for a developer to pick another indexer if they don't like the performance they're getting out of the indexing. So this mechanism is informed by all these concerns, and it's meant to be complementary to curation plus rewards. So curations and rewards are not being changed at all by this GIP, or not being proposed to change in any way. And so the hope is that they can live side by side and sort of complement each other for now. So at the core of this mechanism, there's an indexing agreement, which is what the gateway sends the indexer. This indexing agreement basically says, I want you to index this particular subgraph. I'll pay you this much amount per unit of work done. This unit of work done is a special concept that I'll define a bit later, but simply think of it as the amount of effort it required the indexer to index this particular subgraph. There's going to be a maximum amount payable to do the initial indexing. And then there's going to be a maximum amount payable for the ongoing indexing, plus a maximum amount of time that can elapse between payments. And I'll talk a bit more about this later. But essentially, what we're trying to deliver here is a way for both parties to agree on a price for something that ultimately no one is really sure how much it's going to cost, because upfront indexers don't really know how much a subgraph is going to cost them to index, and neither does the developer, right? So if they can agree on a price around how much they're going to pay per unit of work done, then everyone is sort of in a better position. And so that's why we put the maximum as well, because we want to make sure that the payer doesn't end up overspending or paying beyond their budget. So how does this actually work? So in its simplest form, and the happy path for all of this, is essentially the gateway escrows funds, and then the gateway offers indexing agreements to the indexers. This is done off-chain. The indexers accept the indexing agreements. This is done on-chain, and then the indexers post proof of indexing, plus they declare how much work they've done for that indexing to collect the payments. This is very similar to how rewards work, except for the fact that indexers will have to declare the amount of work done. I think I'm speeding through this. I'm expecting to do a lot of Q&A at the end, or some Q&A, so that's why I'm giving like the simplest overview at the moment. But anyway, so as I mentioned before, the mechanism is for gateways to pay indexers. So the gateway is going to be picking who is offered indexing agreements. Now, there's a concern of how this is done, right? And at the moment, the gateway is controlled by agent node. So part of this proposal includes an indexer selection algorithm, or IISA, which is the mechanism by which the gateway will choose indexers for this agreement. And as part of that selection algorithm, essentially the gateway will weight the quality of service, the historical quality of service that each indexer which it has interacted with has been providing. This includes latency, uptime, error rate. It will also look at things like available stake and other concerns, so as to make a fair choice and a balanced choice that will both benefit the network and the consumer. This will all fall on the gateway. So far, I've been I've been talking about sort of the smart contract approach to this and sort of the fully decentralized solution. Before we get there, there is a sort of MVP or minimum viable product being worked on right now that is doesn't require Graph Horizon or the Subgraph data service to be live on chain. And so for the minimum viable product to work, it requires an update to the indexer stack. And it will be reusing what we have on chain now. So payment collections will be done via query ravs. We'll be using a work done proxy that is basically the amount of entities stored in a subgraph and the amount of blocks indexed in that subgraph as a way to calculate how much to pay for the indexing. And it has this being centralized and mostly off-chain, it has different trust implications. Mostly that indexers will be having to trust the gateway more than in the permissionless, trust minimized on-chain version of it. But this will allow us to sort of test the waters in terms of pricing, in terms of adoption, in terms of the mechanism. And so by the time we get to the on-chain version, it'll be better designed. So that is in a nutshell what indexing payments will look like, or what's being proposed at the moment. And I open the floor for question and answers.
Matthias, one question from my side. I'm still looking at the chat, and thanks again for walking us through the GIP. Maybe I missed it, but who's going to set those upper and lower bounds on the cost, like for those units of work, entities created, and all of that? Who's going to set up the price initially with the MVP?
So
Is it the gateway?
Yeah, initially it's the gateway, and initially we're looking at setting one global price per entity and one block price per chain. So independent of subgraphs. Ideally, down the line, there's a marketplace for this, and so there's price discovery and everything else that a marketplace brings. But right now, in its simplest form and in the MVP version, it's going to be sort of a gateway decision. And if you think about it, there's also the other side of this, where the gateway will have to, on the flip side, charge its developers or the ones interacting with the gateway for this service. And so those two things need to line up. The amount a developer is paying in fiat, most probably, versus how much the gateway is paying in GIT to indexers for that service that it's proxying.
Yeah. And so this is to ensure that there is some quality of service expected. As in, if I do pay for indexing work, indexers need to commit with serving that type of, offering that do that job, do that work with the expected quality of service, right?
I mean, yes, the way it's being proposed, it's a bit different. So all of that is that responsibility falls on the IISA, so the selection algorithm, to essentially pick up historical high performers to give indexing agreements to, in the hopes that that history repeats itself in the future, right? And also, it's up to the gateway to monitor that performance going forward. And if it's not happy with it, it can drop agreements and sort of move them around to other indexers. But conceptually, there is no guarantee that the indexer will perform to the level, and there is no punishment or sort of the price for performing is to keep the agreement going, and sort of the only punishment for not performing is the cancellation of the agreement.
Yeah, guarantee is not the right word. It's hard to guarantee anything on a decentralized network. So I shouldn't have said guarantee, but it just gives the developer more of a better understanding of what to expect once the developer is paying for something, or
yes,
ensuring
and
that data gets
sort of
indexed.
there is that tying sort of that correlation between the developer paying and then having some optionality as to how the subgraph is served. So maybe down the line they can pick indexers that are sort of have different characteristics, so less latency or more regions available, or whatever they're interested in. Like each developer can pick their what they're interested in. But since they are the ones paying, they can sort of move the agreement around until they get sort of optimal performance for their preference.
Yeah,
which is
consumer
something.
preference would be nice.
Yeah, consumer preference, exactly, right? Which is something that they cannot do right now with curation.
Exactly. Yeah. I know the GIP is still open and open for feedback, still socializing, but when do you expect this to go live? Should the GIP pass in the upcoming weeks? Like, how ready are we? Because indexers will also need to adapt their stack, correct? Has there been any work there as well?
Okay, so, yeah. So the timeline right now is for the MVP version of this, which is entirely off-chain, for which indexers would need to update their indexing stack, and agent nodes needs to deploy their gateway. That is early Q2 of 2025.
I would say that sounds reasonable. Just please always take all timelines with a bucket full of salt.
Yes, of course. Yeah.
So to get there, we need to finalize the work on the indexer stack and the gateway, the agent node gateway. Get that sort of tested and deployed. We need to finalize the pricing and sort of socialize the pricing and find something that makes sense. And those are the main hurdles for the MVP, which is I think what you were asking about. Because the full version is actually reliant on Horizon. Sort of the on-chain version is reliant on Graph Horizon and the Subgraph data service. So if at best it could be a fast follow-up on the release on that.
Can you just clarify? I think I have an idea, but can you clarify how this may or may not impact indexing rewards?
It doesn't impact indexing rewards at all. In fact, under Graph Horizon, there is a stake to fees ratio, which means that for every query fee and indexing rewards, you need to have a certain amount of stake to collect them. And query fees and indexing rewards go on different sort of swim lanes. And the plan is for indexing fees to go on the same swim lanes as query fees. So essentially, whatever stake you have you're using for indexing rewards, you can reuse that stake for indexing fees at no extra capital cost for you.
In the future, I don't know if folks have seen REM's proposal, that is GIP 70, that is kind of independent to GIP 81 that Matthias presented. In that hypothetical future, we would have a change where at least part of the current rewards move to network payments, where through a governance mechanism, a set of gateways distribute indexing payments instead of rewards. So that would be a way of using GRT issuance through this mechanism as a way to incentivize indexing and incentivize QoS at the same time. But it's a separate proposal to be discussed separately, but just to show that there is a possibility that in the future we could use indexing payments to distribute issuance, but there would have to be some level of governance to figure out who can distribute it, how, and how do you ensure that the index selection there is fair, right?
I just wanted to sort of summarize that GIP 0081 doesn't change rewards at all. And in fact, it is sort of thought as a complement to it, in the sense that it tries to cover the use cases where curation plus rewards doesn't work, as opposed to fixing anything that curation and rewards, fixing that mechanism. It's meant to complement it and sort of provide the network with value where the existing mechanism is not doing any of the work.
And Pablo says, and it can be used on chains that do not have rewards enabled yet. Yeah, that's a good point. Yeah.
Or even subgraphs that don't have rewards enabled either.
Yeah. All right. Thanks, Matthias. Thanks, Paulo. I don't see questions.
Thank you.
No more new questions. No. Yeah. And we're almost at time, so we can wrap it up here. Again, thanks all for coming. This will be on YouTube as always. We're going to post some show notes on Twitter and the forum. And moving forward, we'll also be streaming this to Twitter. We've been seeing some nice results with Builders Office Hours when streaming to Twitter as well. Lots more people joining live. So I'll see you in a month. Thank you all again, and happy holidays.